Right. So it's a bit of a, I mean, it's not a massive topic, but it's big enough that I guess different people have got different pieces of information. So focus on BLE specifically. And I know we've talked about some people have talked to me about BLE before. I've been doing bits of BLE for a few months at home, but also at work. We've been using mostly TI parts actually. You tend to come out, and there's quite a few manufacturers that are doing BLE for reasons I'll come to. But the NORDIC parts and the TI parts tend to be really, really popular. And what you do is you find them on boards now. So the old HC05 board, which I'll show a picture of in a minute. You can get versions of that like the HC19 that got BLE chips rather than Bluetooth chips. So let me get on with the presentation and maybe answer some of your questions. So I'll send out these slides afterwards, hopefully as a reasonable summary. So Bluetooth, BLE is Bluetooth Low Energy, right? And it was formerly marketed as Bluetooth Smart. And originally it started as a totally separate wireless protocol that was adopted by the Bluetooth SIG. And it's different than classic Bluetooth, right? It's different all the way up and all the way down from classic Bluetooth. There's no, specifically for what we do with robots, I guess, there's no serial port profile, right? What's also called RF-COM. So you can't, it's BLE itself, Bluetooth Low Energy, has got no standard serial stream interface at all. As you probably remember from Bluetooth, there's various profiles for doing different jobs, but a lot of people just used it as a serial port, an extended serial port. And that included not just us and hobby electronics, but also a lot of the commercial products that use Bluetooth are just serial port profile. So, and specifically from an application point of view, because unless you're getting involved in the transmission side, or maybe if you have to do firmware updates over BLE, which it wasn't really intended as, it's really about sending small bits of data over a link, and the sort of conceptual reason for it is a very low power, low cost sensor type protocol. That's really sort of what's original niche is. Now there's lots of people pushing it beyond that. A load of people want to put BLE wireless headsets and streaming data, and none of that was really intended for BLE. And the sort of mode that BLE stacks operate in is basically some sort of object-based or data-based entities or attributes, if you like. And the idea is you can read or write from particular parameters, a bit like what would it be? A sort of informal database in the loosest sense of the word. So you've got the ability to read and write parameters from like a PC or a central. You can also get notified of changes on those attributes. So there's also a lot of people, I've got friends of mine who are involved in device-to-device stuff like cow monitoring. There's a spin-off at Glasgow University who's doing a bunch of Bluetooth stuff, and I know they're doing medical devices, and a lot of it's device-to-device, but I guess for the stuff we want to do, generally it's device to either PC or a device to mobile. And that's there's two sort of pieces. One's the device, one's the central. So the central generally is the one that maintains, like a PC, that maintains connections to these devices. That's sort of the overview, right? So it's originally a very different use case, although, as I mentioned, there's plenty of people extending it to do other things. And in terms of commercial products, obviously you want to do a firmware update maybe over this interface. So that's really not what it was aimed at. To give you an idea, before Bluetooth 4.2 was introduced, the maximum data payload you could transmit was 20 bytes. So it's it's actually wrapped up in what's called a GAT attribute, and that's wrapped up into an L2 cat, which you can do fragmentation with theoretically. And that's wrapped up in another payload, as per all of these protocols. But generally, before 4.2, which was the DLE extensions, it was 20 bytes maximum you could send on a particular characteristic. So let me talk a bit about why BLE, right? And you see a lot of, you go to Amazon now and do a search, and things like the HC05 are sort of disappearing. And the reason is really is Apple and iOS, right? So what happened is that Apple never certified the serial port profile, right? So they've certified with Bluetooth Classic, they certified a bunch of standard profiles they thought they needed to support, things like keyboards, headsets, that sort of stuff. But they never standardized serial port profile, which meant that any device, if you're making a thermostat, or if you're making a microwave, or I think even my washing machine's got Bluetooth in it, right? Any of those devices, basically it rules out any iPhones or iPads, right? So for a device manufacturer, for the chipset manufacturers that supply these, that's basically led to Bluetooth Classic sort of being in decline and Bluetooth LE really being pushed. So with Bluetooth Classic, you had to go through Apple approvals to get new profiles, and it was just a big challenge for various reasons. Whereas with BLE, you can do what you want with it on all platforms, including iOS. So that's sort of driven a shift overall to iOS. And to be honest, there's still a certain amount of catch-up happening. If I cover the operating system support. Now, pretty much now, all of the main operating systems are pretty well covered. Certainly iOS, excellent. Android, very good. I've been using Windows 10 for some test tools at work. I'm actually using, I don't know whether I cover this, the Adafruit BLE library that runs Bleak underneath. Now, Bleak is a cross-platform BLE library that runs on macOS, Linux, and Windows. It seems fine. I've been testing devices for months on it. So yeah, it's got good cross-platform support. If you've got older versions of Windows, and allegedly Windows 8 has native support, right? Personally, I wouldn't want to support any of them before Windows 10. And if you're on Windows Phone or BlackBerry, then apparently they've got native support, but good luck with that. There's also a bunch of documentation, especially on iPhones, if you end up with an iPhone app, to tell you which models have got which. So the one thing you come across, especially if you're doing an app or something, is that the different operating systems have got different levels of support, and the hardware itself, so the chipsets, the wireless chipsets have got different levels of support as well. That's a bit of a pain. So if you're talking about like an iPhone 6, that might only support Bluetooth 4 or 4.1. So it might not have the data link extensions which allow you the bigger packets. But there is a good amount of information. If you're Android phones, things like 4.3 or later, it's very good support, but getting details of which phone supports which version of BLE, not just the operating system, but which bit of hardware is much more tricky. Okay. So again, a bit of a slide with lots of text on it. So this is sort of the terminology, the basic terminology. I didn't really want to have a sort of a BLE, how to do it, but really where to start. You've got the central, the phone and computer, and a device like perhaps like UKMARS, but that's the peripheral. And then all of the protocol itself from an application point of view is all based on attributes. So you've got a service, say you've got some sort of I don't know what would be a good service to give you an example of. I don't know, like a movement service on a MicroMouse, right? You break that down into characteristics. So you might have the speed as one characteristic. You might have the angular velocity as another characteristic. And in those characteristics, you actually use several what's called attributes, which is the GATT protocol, to implement that. So the one attribute will be the actual value reading, like the speed. But you'll have another attribute that tells you that if the central wants to discover whether it can read to it or write to it, or even wants to get notified, there might be an attribute so it can get notified of any changes. Those are attributes. So you use several of those attributes usually to make up a characteristic, and you use those characteristics really what we think about from a data point of view, like the speed. And then those characteristics are built towards a service, which is a collection of characteristics which make this service. So GAP is the advertising protocol, and GAT is the actual when you connect it. So you can discover stuff if you've just got a beacon, a BLE beacon, which I guess you've all come across. These are usually advertising only devices. They only do the GAP protocol, and what they'll do is just broadcast a block of data. And depending on whether you're pre-BLE 5 or BLE 5 and above, that's how many bytes you've got. And then inside the GAP packet, there are several attributes. One of them might be the device serial number. Another might be the transmit power. And there's a list of attributes that standard attributes you can use. But you can also make your own attributes up to broadcast this information. So usually that's what those advertising packages are. Usually when you discover a device that's on before you connect to it. I guess for our case with MicroMouse, where we want to transmit a whole bunch of data, the advertising is generally what we just use to connect to the device, and then we'd be on the GAP protocol and transmitting and receiving attributes. All of these attributes are identified by a unique identifier. So there are standard ones that are 16-bit, and then open or custom ones at 128-bit. Now, what you do find, I actually haven't got it here. I've got something that looks like a HC05. I think it's a HM19. I think it's a Texas part that's inside it. That's actually got 16-bit non-standard attributes in it, right? So what you're meant to do is custom attributes meant to be 128-bit, and only the standard ones are meant to be 16-bit. But obviously, there's no Bluetooth police, right? So unless you're trying to get your device certified by the Bluetooth special interest group, which I guess if you're big enough you would, but most companies don't, and certainly we wouldn't, then there's nothing to stop you using 60-bit attributes. 60-bit UUIDs. So that's sort of let me just pause there because I've just downloaded a whole bunch of information in 3 slides. If anybody's got any questions, let me know. Otherwise, I'll carry on. You can ask questions when they occur to you. So this is all background material so far. Okay, let me go on a little bit further then. So, although there's no standardized way of transmitting serial over BLE, obviously you can transmit serial over BLE. So NORDIC especially, and that's if you have a look at the Nano 33 BLE, that's a NORDIC part that's on there, right? So their Arduino, the BLE 33, that's a NORDIC part that's actually running the show there. NORDIC themselves have got some sort of what they call a NUS or a NORDIC UART service, and they've got a sort of a NORDIC set of UUIDs that they use for transmitting and receiving serial data. So, as I said, the Arduino 33 BLE's got one of those on. On the screen, there's a FanStel part. So this is an off-the-shelf module you can get from somewhere like DigiKey. It's a bit tricky to solder. I've got a couple of those. That's a NORDIC part as well that uses the and you can reprogram it actually. I mean, you can put your own firmware in there if you wanted to. So that's a serial module that's got the NORDIC UART service in. If you have a look at some of the other ones, I've got some of these HM19s. You can get them just as a sort of castellated board, or you can get them on a carrier board, much like the HC05. Those are TI chips. That's I think it's the last generation, so it'll be a 2540, CC 2540 on there. And that's got, as far as I can tell, I mean, I've got the documentation. I think it was developed originally by a Chinese company that got annoyed because a lot of their countrymen just made copies of the HM19, which I think annoyed the original company. So that uses pretty much non-standard UUIDs, but they're not overly difficult to discover, and I'll show you a bit about how to do that in a minute. I've also got, you also get off Amazon, something called a BLE Nano, right, which is a company called Kiwish. I guess they're probably another Chinese company. And what they've done is they put a 328, so it's a standard Atmel 328 like you get on a Nano. And next to that, they've put a TI CC, probably 25, last generation 2540 next to it, which does both BLE and the USB interface. So they got rid of the USB chip, and that's about, I don't know, $10 or something. The only problem is, over a standard Nano, is they didn't put the resistors between the Texas chip and the Atmel 328. So I'm not sure how well it'll take to be double driven from an external interface. From a theoretical point of view, I'm sure the Bluetooth people would tell you that it's a bad idea to send serial over BLE. Although I suspect about 50% or more of commercial products actually do this, right? Because they've already got existing protocols, you see, that are serial-based as opposed to attribute-based. So generally, the part of the reason for BLE was that they wanted to be able to keep the data owner and the data model in effectively as close to the stack as they could, so they could avoid extra transmissions, they could lower the power, they can reduce the latency. So if you've got multiple micros, obviously if you get requests, you've got to keep that radio alive for as long as it takes to round trip that through the other micro, maybe, get the data, reformat it and send another set of packets. Whereas if the stack with BLE, the way BLE was organized with these characteristics, the stack itself is aware of the actual data. So if you've got like a 12-byte string, for instance, that's listing the last error code or something, the idea of the BLE is that the stack has got direct access. You've got an agreement between the application and the stack, and the stack can just send that data information straight up to the central without having to go through the application or go through a second micro. Obviously, for any cases where you want to send a whole bunch of data, then you tend to end up maybe streaming it. So, for instance, Pete with his everybody with his streaming serial data from the sensors, then you're probably doing that anyway. And generally, we don't have battery problems. We're not running on for long periods of time on very small cells. So the other thing is that there's a bunch of pretty good generic BLE applications, right? So unlike with Bluetooth, and there are some Bluetooth applications, these things can show you what devices are advertising. It's quite sometimes surprising how many BLE devices you actually got in your house. I must have over 20 BLE devices in my house without even trying, and I don't even know where they all are. And these applications can show you what's advertising, allow you to connect to it. Some of them, like BLE Scanner and Light Blue. So Light Blue is not done by a consultancy called Punch Through. They've got a load of really good information online. Even the TI Starter application and the NORDIC RF Connect can show you what the attributes are. So you can connect to it, have a look at the characteristics, and if you're developing something, sometimes it's useful just to see the raw data. If you've got a problem, so those are pretty good, and they look like this. So this is BLE Scanner. So as you can see, I appear to have a bunch of echoes in my house. I've also got my son's phone there and a display board, which I developed over Christmas. I'll show you a bit of that code in a minute. And then when you connect to this, so you can see this on some of these applications, you can see the advertising data as well. When you're actually connected to this, and this is connected here, so this is the advertising data for the display board, which I developed over Christmas. This is using a Nano 33 BLE. So you've got what the advertising data contained the local name. It contained a service UUID, so that's sort of for discovery. So if you imagine if you're trying to discover your particular device as a commercial manufacturer, and then trying to identify that it's really your device, even before you connect to it, it's important. And then you can connect to the services. So you might have several of these services. So for instance, the TI Launchpad has got, in the default application, has got a service for controlling the LEDs, a service for reading. What else does it do? Oh, reading some onboard sensors, that sort of stuff. And then it's got another service for over-the-air firmware update. And then when you go into this service, you end up with this sort of screen, and so this is the display board, which is something I built over Christmas. It's got NeoPixels. It's like a 24 by 24 LED NeoPixel display driven by the Nano 33 BLE. And then I set up here a brightness characteristic. So this characteristic got this 128-bit UUID. Luckily, you don't need to remember that. You just need to be able to type it into code or copy and paste it from code, actually. And then you've got this property can be read and written to. So the value of it at the moment is 80, which is probably half brightness. So this read and write, it knows that because it's read an attribute, right? So there's several attributes. Then there's an attribute of the data value, and then there's a description attribute as well, which is optional but useful for if you're playing with these things. And then the second one is got a display mode, which again is a read-write property that's got a particular value. In this case, it sets what display is on the LED. So there is some example code here. I wish it was robot-based, but it's not. So you'll have to just live with it. Let me just show you what the display board looks like. If I can find this stupid thing. Right. So the display board looks like this. It does shows, well, Holly in this case, but it cycles around different spaces. This is before I put it into a picture frame. And then it's got a Arduino 33 BLE connected, just clocking. If you know NeoPixel, they use a single data line that's sort of pulse width modulated for the data. And then it's got a giant display because we've got a gazillion LEDs on there. So the code for this, if I just zoom up on this because nobody will be able to read that. So this is Adafruit's NeoPixel library and Adafruit BLE, right? And the bit that does the BLE services is this here. So as you can see, because this is, what is this anyway? Oh yes, it's an Arduino project, of course it is. So it abstracts a lot of the, if you do this with the native TI or NORDIC libraries, you end up with a file worth of code. But this is fairly well abstracted. So this is probably what we'd use for most of our robot stuff, I guess. Set up a service, there's a UUID. I probably generated that randomly. Now, there is a particular format for UUIDs. This is a standard UUID. So UUIDs are one of the bits means whether it's an old format or a new format, all that sort of stuff. I think I just put it in the UUID generator. And then you tell it you've got a characteristic and you tell it whether you want it read, write, there's two other ones. One's Notify, which allows like a laptop or a mobile phone to get notified when there's a change. So for a serial port profile, and for a serial port, you'd want Notify on your PC app or on your mobile phone, because you'd be writing multiple blocks into the characteristics, you see. I haven't got it for this. And then I've put a descriptor so I can see when I use the mobile app. And that's pretty much it. So in terms of the actual code that handles it, you can set up a sort of notification. Let me see where I do that. Show you how I. So here you set up an event handler. You add the characteristic in, you set up an event handler, and then every time it changes when BLE is written, it'll call that function. And that's pretty much it. Adafruit themselves, in the Adafruit BLE library, they have already got existing characteristics for some useful things. So transmitting different types of numbers, for instance. They've also got, for the NORDIC UART service, which is the one that's sort of semi-standardized, they've actually got a service that you can just set up that allows you to transfer data. And the documentation is pretty good on the Adafruit library. So let me just talk about a couple of the changes. So BLE 4.2 brought in a data link extension. So the payload size, once you've taken the gap, so the L2 cap header, which is the way it manages fragmentation, is 4 bytes, and then the GAT header is 3 bytes. So the realistic largest amount of application data you can send after BLE 4.2 is 244 bytes. Now, after that, obviously you can send more than 244 bytes, you just need to do it in chunks, right? So either you can manage those chunks at the application layer, right, which is what a lot of the standard services do. You can theoretically get the L2 cap layer to fragment it, right? But most people don't. I don't know why, because I haven't investigated it deeply enough. But generally, I suspect if you're transmitting a bunch of serial data, that you'd probably use a standard like the NORDIC sort of semi-standard serial port characteristic. There is also the complexities that if you're using these existing stacks without changes, they usually are pretty good at negotiating the MTU. So obviously, the hardware of the device and the hardware of the central, like the phone or the laptop, and the stacks, the BLE stacks in both sides, sort of depend on what sort of MTU, what sort of biggest payload you can negotiate. But generally, that's pretty much hidden from what's it called? I guess there's reports of lots of people having dropped fragments if you fragment at a lower layer, like the L2 cap layer. So generally, they handle it above at the characteristic and the characteristic level. Bluetooth 5, interestingly enough, has got support for a faster transfer. Obviously, it's speed versus distance. So they've got support for longer distance via coded, which basically means combining symbols. And they've got support for higher speeds. And if you really want to transfer a load of data off, like, the case that I've been involved in is Ferber update, which is a bit tricky when you transfer, fractions of a megabyte. You've got, you generally, if you want to tune this sort of stuff, you need to sort of optimize, get the biggest MTU you can. And then there is the BLE's got this sort of interframe time where it goes and checks if there's anything there. So if you want to speed it up, you generally reduce this into frame time. I don't know whether any of us are going to hit that, although I know we've previously talked about, 115K not being really enough. But anyway, actually, Punch Through, do one of the applications, has got a bunch of really good descriptions of if you want to optimize transfer speed, what to do. So the other thing is probably for tools for programming BLE. So I've done a bunch of stuff in Python with the Adafruit Circuit Python BLE, which is based on this Bleak library. And that seems to work on Windows, Mac and Linux and Raspberry Pi. There's lots of, if you're just doing it for Windows or just doing it for Linux, then there's quite a lot of platform tools. A variable support, right? And the thing that attracted me to Adafruit wasn't just that it was cross-platform, the fact that they had a lot of documentation in it and it seemed to work. I meant to fill this in, but I haven't got around to it. So mobile cross-platform is more tricky. You're probably better off just focusing on a single. Obviously, you can do it for iOS using the native Apple libraries. You can do it for Android using the native Google libraries, but if you want to produce an application, that's a bit more tricky. There are solutions like some of the GUI libraries, the big GUI libraries, have got plugins for it. I'm trying to think of the one I'd come across, but it's escaping me now. So the other thing you might need is tools, which is I mentioned for the mobile applications. They're really, really good. Windows, I've tried 3 or 4 different BLE tools and they've all been extremely terrible. On the Mac, there's one called Blue Sea and Light Blue. Light Blue is produced by the same people that Punch Through on the mobile app. They're really good. And Linux, I don't know at all. Obviously, you probably want to do it from a command line if you're doing it on Linux. So, yeah, and that's a reference to the. Oh, that's my only reference. Obviously, I meant to add more in. So, a lot to cover, and I'll obviously we'll get this on the. Distributed this set of slides. I mean, it's pretty easy to get Bluetooth data out. In summary, a lot of devices are starting to add it on now, which is, I think, it's quite good. Obviously, if you're using something like Pi Zero W, and that's a sort of cross-platform chip that's on there that can do Bluetooth and Bluetooth low energy. But a lot of the sort of embedded chips tend to be just BLE. Are you all there? You're all falling asleep.
Still here. Any questions for Rob?
Yeah. So, do you think it's worth looking at, or we just stick with what we know? Because I couldn't see anything jumped out as wouldn't it be wonderful? We couldn't do that in any other way.
I mean, I agree. I mean, I think the HCO5, if you can stand the weight, which is not very heavy, with PCs just works, right? There's really good support for it, and everybody knows how to use it. You just connect the serial pins up, and you're away. That's assuming you can configure the baud rate of the bloody thing. But if you've got yeah, that's it. It's variable would be the answer to that question. But if you've got something like the Nano 33 BLE, right, then I think you'd want to use the BLE chip in there because it's built on, right, and it's got a 9-axis accelerometer, magnometer, gyroscope on it.
Yeah, like one of those.
Yeah, so I think you've already got a reason to use it, you see, Derek. To be honest, it's on your chip already. So, I mean, I bought a few of the HM19s and the ones with the sort of equivalent to HCO5, but I'm still using HCO5s, right? if you want to just pipe it into a serial port, then you have to figure out a way of getting the attribute data and emulating a serial port to do. People have done it for all the different, what's it called, but natively it doesn't come in as a serial port to your computer. So you either need to write a bit of custom code that talks those attributes and then turns it into a serial port, or you need to, there are libraries that effectively produce a virtual COM port out of the attribute data. So if you buy like the HM19, the guys in China will give you some sort of system library that scares me the living daylights out of me, because they're usually not well maintained. So that's the problem with BLE on the PC side, at least, not on the mobile app side, is that it doesn't come in as a serial port natively.
And there's no easy way of making it into a COM port.
Well, I mean, some of the manufacturers, if you buy I'm not sure, maybe what you need is a serial port driver of some port.
Yeah.
Right. So now I'm not sure whether NORDIC do one for their NUS protocol. Maybe they do. I haven't done a lot of these. On this, I was using which were on the LED display, I was using native attributes. That's what I wanted to play with rather than serial ports. So I was just reading and writing from the attributes you see on the PC side. But if you want to use it as a serial port, then I think you need to install some sort of COM port driver that turns those attributes into a normal serial port. And it depends what device you've got as to the support for that. So definitely look for that. If you want to treat it as a serial port, make sure you've got a driver that changes it into a serial port.
One of the questions perhaps that you need to ask yourself, I think, is what do you want this serial port for? And if your serial port is for sending out a couple of characters and getting a modest chunk of data back, you don't really need a serial port.
Yeah.
And the BLE protocols have that kind of thing already available to you.
Yeah.
Though when I say available, it's a bit like saying, if you give me some bricks, I can build a house. If, on the other hand, what you want from your serial port is a flow of two-way communication where you type in lengthy commands and you get answers back, that's a different thing. But if you can codify, I believe anyway, right? If you can codify your requests to the remote device into small, simple, kind of atomic requests, then probably you can make this work. Having said that, I played with the BLE, the Nano BLE, became horribly dispirited and decided that if it was easy, I would be able to find prior art, and I can't.
Yeah, I mean, the Adafruit stuff is great because they've obviously spent a load of time, and you have to be careful, of course, because they've got an older version of the library, because things have moved so much in the last 5 years have totally changed BLE. So the Adafruit one was the one that I looked at, and the Python libraries on the desktop side. That you can see I'm using the Arduino Adafruit BLE libraries, and that made it a lot easier when I was doing it. But yeah, I mean, it depends whether you treat everything as a serial port, which is typically the way in the embedded systems we've got, right? The problem for low energy devices, it just doesn't work, which isn't really what we're into. I mean, I think the interesting is if you need some sort of remote control app, if you've got an iOS app, if you want some sort of live app as opposed to a PC, then you're going to have to go BLE. If you've already got a device with BLE, that's going to drive you towards BLE. I think on a normal robot where you're controlling it from a PC and you've got something like HCO5 attached to it, then BLE is less attractive.
You talked about real-time control, controlling it like a radio-controlled car sort of thing.
Yeah.
What sort of latencies are you getting through this system?
It's an interesting question that I hadn't expected to come up. I mean, it depends on what you set the retry time. So I think the minimum is, and it depends, it's not just set on the device end either. I think the minimum round trip are in the milliseconds type time domain, Some of the phones won't allow you to get down to the absolute minimum time intervals, and obviously it depends on how busy that channel is. The 2.4 gig channel isn't. It's got a lot of facilities to avoid noise, but some of those obviously end up increasing latency. If you've got a lot of 2.4 gig things in the band. I can get you more exact figures if you're interested, Duncan. It's not a problem.
I can't see me ever using it. It's just too much overhead.
Yeah.
The HC05, as you say, you can buy it without the header, so it's quite a lot lighter, and you can't run very high data rates over it. I've never got above about 19.2 without Windows falling over at one end or something else falling over at the other end. But sustained. You can do short bursts of other things, but you can't sustain it. So I would very much like to have something that's faster.
Yeah.
But
I'm not sure.
I haven't got 3 months to spend making it work.
I'm not sure BLE's faster. That wasn't BLE's use case, although, that's not really BLE's use case. Lots of people are using it because of the iOS problem, and because that's driven it onto lots of embedded chips, lots of them. And so that means that you end up coming across it a lot. But it's really reasonable as low energy, sensor type or beacon applications or that sort of stuff. People are using it now in, wanting to produce headphones with it, which it wasn't within its, within its original design envelope.
Okay. Any other questions?
I think in terms of latency, I'm pretty sure that some of the console controllers and things use it to connect, so they can't be bad.
Yeah.
Would you expect a normal sort of Windows PC or laptop to support BLE? Has it been supporting it for quite a while?
It depends. Certainly the situation in 2016 was terrible. Does that give you a better impression?
Yeah.
So my laptop, I got a new Windows laptop last year. Not a particularly high-end model. It's got BLE and included Bluetooth and BLE, and I'm running a stock version of Python. I did a pip install Adafruit BLE, and I'm using that all day to connect to BLE devices. But I think if your Bluetooth chip is older than in your laptop is older than a couple of years, you're probably going to struggle with it. Now you can get dongles, right?
Right.
But so that's going to be a limiting factor. A lot of this from a technology point of view, it's ages, but in reality, it's just a few years, right? A lot of things are still sort of catching up with we had a discussion about whether we could rely on BLE 4.2, which was released 2015, 2016 type with extra kits. And obviously, if you've got people with phones, they're easily older than that. So you get into conversation with like that. So I think, especially on the Windows PC side, the Macs have been supporting it for a good number of years now, which is why the support's got really good. And if you have a look at some of the articles that are sort of 3 or 4 years old, even Linux was suffering with problems. Right, the Blue Z is the library that's the Bluetooth library in Linux. But Windows 10 itself has got good support. And Windows 8, I've got a Windows 8 machine in the house which I've been meaning to reformat forever. I wouldn't even try it. But I suspect your constraint's likely to be the built-in Bluetooth transceiver on laptops.
So just to be clear, you said that the Adafruit Bluetooth library, which
CircuitPython, Adafruit
version, although they bang on about CircuitPython all the time,
it's part of CircuitPython.
Sorry,
it's part of CircuitPython. The Adafruit.
Sure, no, that's not the question. The question is, you said that you can load that up on your desktop machine.
Yeah.
The Python 3 on the desktop.
Yeah.
Assuming your hardware will play ball.
Yeah.
That's correct, is it?
Yeah. I've written it from scratch. I've written a Python app that we just import Adafruit BLE, and I talk to the native characteristics on it. I can recognise the advertising packets. I was actually quite surprised. It just works on a Windows machine. I'm sure it would work on Mac. And
If you could make
as
such
well.
a sample thing available, that would be interesting.
Yeah, okay.